Hello, and welcome to this demonstration of Veritas InfoScale. My name is Joe D'Angelo. I'm the Availability Practice Lead at Veritas, and today I'm excited to show you how, with our InfoScale Enterprise solution, you can easily migrate workloads from on-premises directly into the public cloud. The example used for this particular demo will be a MySQL cluster running on Red Hat Linux in VMware, migrating to a secondary cluster located in the AWS cloud. The primary means used for this migration will be the Veritas Volume Replicator and Global Cluster options. Let's begin by reviewing the on-prem and cloud environments we'll be using. Starting with the AWS side, here you can see that while we have a number of instances configured, we are concerned only with the two systems appended with the suffix of Node1 AZ2A and Node2 AZ2B. These hosts are what our InfoScale cluster in the cloud comprises, which I will note span separate availability zones of the same region. It is therefore worth pointing out that each system is, by design, configured with its own independent EBS volumes. Moving back on-prem, we now see our VMware environment. The two guests we'll be focused on are InfoScale 1 and InfoScale 2. While we won't be detailing the private network and storage layout, we do support a variety of cluster topologies and storage options in VMware. These include standard VMFS data stores with VMDK and RDM devices, as well as vSAN data stores, and even iSCSI directly in the guest. As I stated at the beginning, in order to support the recovery of MySQL between on-prem and the public cloud, we'll be using the Veritas Volume Replicator feature. VVR is a very adaptable replication tool, providing block-based write order fidelity across any geographic distance, with no dependency on the underlying storage media or hosting platform. To administer this environment, we've deployed the Veritas InfoScale Operations Manager. Designed to provide visibility across your entire InfoScale estate, VIOM centralizes your storage management, availability, disaster recovery, and license reporting tasks into an easy-to-use as well as customizable dashboard interface. Assets can be organized based on a variety of characteristics, ranging from business criticality to physical location. In this example, we've chosen to create two subcategories, one for AWS and another for VMware. As we explore the Availability tab, we see listed under VMware Clusters On-Prem a cluster named MySQL_CEC_On-Prem. We can then expand that cluster to view the various resources and applications configured for high availability. You'll see now we have a number of service groups configured on this cluster. By selecting the MySQL service group, we can now view, edit, or update the various objects and resources we are monitoring in support of this application. For example, the data directory or datadir value for the MySQL instance itself. Other attributes with an asterisk associated with it are considered a required value. Otherwise, the fields can be left blank. The first operation we will perform is a controlled failover of the MySQL instance from InfoScale 1 to InfoScale 2. This process will take advantage of a concept referred to as fast failover by using our Cluster Volume Manager and flexible storage sharing features. By simply right-clicking on the MySQL 01 service group, you can then select the target node in the cluster in which you want to bring the database online. Given that this example is of a two-node cluster, we of course only have a single target system to choose from. Once you initiate this failover, VIOM will then immediately display the corresponding CLI syntax needed to perform this operation from the command line. A very useful benefit when considering how best to script these types of procedures. After clicking OK, you will see a task entry reported at the bottom of the screen, as well as an incremental status update for each resource being transitioned. When the process completes, all resources will report as blue on the node InfoScale 2. It's important to note that the steps executed here are the same regardless if they were invoked by a user or in response to the fault of a dependent resource or an entire host. Let's now shift gears and show how the same MySQL database can be relocated to a cluster running in AWS using nearly the exact same procedure described in the previous section. From the VIOM dashboard, you once again select the MySQL 01_SG service group. You'll notice that the service group icon has a halo around it. This indicates that it is enabled for global failover to a remote location. A global cluster configuration logically groups clusters such that a user from one cluster has authority to activate resources on another. By selecting the target cluster and system, you will initiate not only a local shutdown of the MySQL instance, but the replication data flow will be reversed as well. In this example, the corresponding remote instance happens to be resident in the AWS cloud. Once the process completes, you will see how all the dependent components for MySQL are now active on system IP-172-31-1-39. This is the default naming convention for an internal DNS in EC2. It's important to note that included with this failover process are the necessary network updates to support any new DNS entries associated with a Route 53 hosted zone. Let's now demonstrate how to move the MySQL instance that has just been relocated to AWS across availability zones without requiring that any shared storage between the cluster nodes themselves exists. Returning to the Viom dashboard, you again select the MySQL 01 service group, and just as we did on-prem with the VMware setup, you simply select the passive node of the cluster. In this case, IP-172-31-19-192. What this internal hostname represents is that this EC2 instance resides on an entirely separate subnet in addition to availability zone. What's allowing for this process to complete is a feature referred to as FSS, or Flexible Shared Storage. Simply put, EBS volumes which exist in separate AZs can be mirrored using Cluster Volume Manager. Applications are unaware of this process as they interact directly with the file system or volume, which entirely abstracts the underlying storage layout. This also means that applications can be moved rapidly between AZs, as the storage devices needn't be altered or migrated, as would be the case with a traditional local HA failover. You now see that the services have been successfully moved to the alternate node. Let's now complete our demonstration by showing how the MySQL database can return on-prem back to VMware. By selecting the MySQL 01 service group from the AWS cluster, you can now choose to remotely switch its active node to any system from the on-prem VMware cluster. Veritas Volume Replicator works equally in both a standard private disk group configuration as well as shared disk groups with Cluster Volume Replicator. Once you've selected the target node and initiated the failback, all MySQL services will be taken offline in AWS and brought back online in the local VMware environment. This concludes our demonstration, and I thank you for watching this video. To learn more about all of the capabilities included with InfoScale, please be sure to visit veritas.com/availability/InfoScale.